Namaste, welcome to Pythagoras Academy. This is Vikram Dachepally. Students who come to me right after finishing their 10th class come with the misconception that mass and weight mean the same. But it is not true. There is a lot of difference between these two physical quantities. So I am making this video exclusively to clear that confusion which is prevailing among many students. Let us first try to understand the meaning of mass. So we have matter around us, and matter is made up of so many molecules, and molecules are made up of so many atoms. And we have the basic atomic structure proposed by Niels Bohr, that there is nucleus inside the atom, which is consisting of protons and neutrons. And around this nucleus, electrons revolve in circular orbits. This is the basic atomic structure. Atoms like this, several atoms like this, will combine to form a molecule, and several molecules combine to form matter. These elementary particles of an atom, like protons, neutrons, electrons, and whatever the particles that exist inside the atom, they possess a very, very basic property. The name given to that property is mass. So atom has got certain mass because the elementary particles of atom have got certain mass. It is impossible to define the concept of mass exactly because it is a basic property. So we have taken mass as a reference to define other things. Like I have taken mass as a reference, so based on that I can define force. I have taken mass as a reference, based on that I can define linear momentum, which is mass into velocity. Similarly, kinetic energy, half mass into square of the speed. So mass is a very, very basic property possessed by the elementary particles of an atom. So an atom consisting of certain electrons, protons and neutrons has got certain mass. We call it atomic mass. Several atoms combine to form molecule. So a molecule has got certain mass. We call it as molecular mass. Similarly, if we hold some amount of matter, the amount of matter has got certain mass. We call it mass of an object or mass of a body. For example, I have this pen in my hand, which is collection of several atoms and molecules and several elementary particles inside it. So sum of masses of all those particles together, I say mass of this pen, which is say 100 grams or 150 grams. This is mass. So I can only define mass in this way because it is the basic property. So any object has got mass. Earth, it's a huge mass. Sun, a huge mass. Now coming to the concept of weight. Weight is actually force. So this is force. The units of mass would be kg or gram. The SI unit is kg. The CGS unit is gram. So we measure mass in terms of kg. Now the problem comes when we use these terms like mass and weight in our practical life. If any of your friends ask you what is your weight, you tend to say that it is 50 kg or 60 kg or 70 kg. But actually the units of weight is not kg. So whenever you're referring to kg, kilogram, you're actually talking about your mass but not weight. So what is weight? Let us try to understand the meaning of weight. Weight is a force. So this is Earth. Consider this to be Earth. So there is a particle or a body of mass m at a height h above the surface of the Earth. So it is at a distance of r plus h from the center of the Earth, where r is the radius of the Earth. Now there is gravitational force experienced by this body exerted by Earth. Earth is exerting gravitational force. So let us talk about this gravitational force. Say F is equal to G, mass of the earth, into mass of the body by the distance between both of them is R plus H whole square. This is Newton's law of gravitation. G m1 m2 by R square. So the force experienced by a body or the force applied by the earth on any body is G m by R square approximately, as R is much greater than H. If we are talking about heights in the order of 100 meter, 200 meter, it is very less compared to the radius of the earth, which is 6,400 kilometers approximately. So if you're talking about very small heights comparable to the radius of the earth, I can approximate R plus H to be equal to R. Now this is m into G is a constant, universal gravitational constant. Capital M is mass of the earth. We know the mass of the earth. And R is radius of the earth. I just said it is 6,400 kilometers approximately. So this is a known value, M is a known value, R is a known value. These are constants. I'll replace G m by R square as a single constant, that is small g, where G is equal to G m by R square. And if you substitute the respective values, you end up with approximately 9.8. The units would be meter per second square. So this is the value of G, which you call it as acceleration due to gravity. Or in other terms, this G can also be referred as the gravitational field of Earth near the surface of the Earth. Gravitational field, or we can also call it as acceleration due to gravity, whose value is approximately 9.8 meter per second square. This particular force mg, this is called as weight. So basically weight is a force, and the units of weight would be Newton and not kg. When you check your weight on a weighing machine, so weighing is the process of measurement. The word weighing is used for a weighing machine not because it is calculating weight, because it is weighing something, it is weighing your mass on the surface of the earth, because we are on the surface of the earth. So when you stand on a weighing machine, if the reading shown by a weighing machine is 60 kg or 70 kg, it is showing the reading of your mass but not weight. Of course, if we know mass, we can happily calculate the weight experienced by us. It is the force applied by earth on us. If my mass is some 80 kg, the weight that I experience or the force that earth is exerting on me would be 80 into G value. I can take approximately 10, 9.8. If I approximate it to be 10, it is 800 Newton. So 80 kg mass on the earth's surface would experience a weight of 800 Newton. Suppose a person of mass 80 kg is going to the surface of moon. What is his weight? It is no more 800 Newton. Now don't think that a person is going to moon, his mass changes. No. What changes is his weight. When a person is going to the moon, then there is a different gravitational field of moon. So this value G is equal to capital G m by R square is the gravitational field of earth, because we have substituted mass of earth and radius of earth. Similarly, if we have to calculate the gravitational field of moon on the surface of the moon or near the surface of the moon, G dash would be, so universal gravitational constant G, m dash which is mass of the moon, R dash which is radius of the moon square. So this is approximately 1.6 meter per second square. The weight of 80 kg person on earth would be 800 Newton. The same person, if he is going to the surface of the moon, his weight, meaning force exerted by a moon on him, would be 80 into 1.6 Newton approximately. Mass is a basic property, whereas weight is the force exerted by earth on a particular particle or on a particular body. Because we are on the earth's surface, we generally take the value of G to be 9.8 meter per second square, and our weight would be m into g. Now what is the direction of this weight? Because weight is a force, it is a vector, it has got both magnitude as well as direction. Now what is the direction of weight? It is so simple. So say this is the earth surface. So consider a spherical body, so this is earth surface. If there is any particle here, it would experience force towards the center of the earth. If somewhere the particle is here, the particle would experience force towards the center of the earth. So the direction of weight is actually towards the center of the earth. But what is the meaning of towards the center of the earth? If a person is standing here, for this person, towards the center of the earth is nothing but the downward direction. Suppose the person is standing here, towards the center of the earth is the downward direction. So the direction of weight is always mg downwards for a particle of mass m near the surface of the earth. The weight acting on it would be, so if this is a particle, the weight acting on it would be mg downwards. Now if I simply drop a body from certain height h, the only force acting on it is its weight, mg downwards. Of course, neglecting the air resistance. And the only force acting on this body is mg. Net force is mass into acceleration. Mg is equal to m into a. The acceleration experienced by a body which is freely suspended in air is g meter per second square, or 9.8 meter per second square. So that is the reason we call it as acceleration which is caused due to gravitational force, or acceleration due to gravity. That's how the name acceleration due to gravity is given to this value g. Actually g is the gravitational field on the surface of the earth. So that is the reason in kinematics, for a freely falling body or a vertically projected body, we always take the acceleration experienced by that is g downwards, which is 9.8 meter per second square downwards. So this is all about weight and mass. Next time if somebody asks you your weight, be sure that weight is force, and when you say 60 kg or 70 kg, it is mass but not weight. You can always convert mass into, if you know the mass of any particle, you can always calculate, not convert, but calculate the weight experienced by that particle. If you have any questions or queries or suggestions, you can always use the comment section to interact with me. I'll be more than happy to respond and receive your feedback. This is Vikram Dachepally signing off. Namaste.